Good morning or good afternoon. It's me, Mr. Yenna. I'm at home doing this, so you can probably hear my daughter Mava or my wife at some time speaking here. So at this point, you should have done the science appetizer, and now you've been given the Igneous Rock Identification Lab. You should have that paper in your hand right now. If you don't, ask the substitute for that paper. And I'm going to guide you through filling in that rock chart so you know how to ID igneous rocks, which you will do for the second half of class today. This is what your chart should look like, except nicer, printed up on a full piece of paper.
10:30.
That's my clock telling us the time. Okay, so I'll kind of fill this in along the way to make sure you're filling it in properly. And then once you have your ID chart, then you can go ahead and ID those rocks, okay? Hopefully you can hear me here. All right, so beginning at the top, we're classifying this based on composition, which is what is actually in the igneous rock, and texture. And we said texture is not how it feels, but it's how it looks. Okay, so when we say it's how it looks, we're looking at the igneous rock as a whole, and we're looking for crystals inside of the rock. Okay, so let's start with texture. Texture, we have at the top PHAN, which for yours says the full word phaneritic. Phaneritic means coarse-grained. Coarse-grained means large crystals that we can see with our eyes. Now, even if it's super small, as long as we can barely see it, if we can make out a crystal, it's still considered phaneritic. So, for phaneritic, on your notes, I'm trying to look at another computer and make sure I have them in front of me. So, underneath it, in the parentheses, you should put coarse-grained, which means that you can see those crystals, okay? Now, the next one down is aphanitic, or you may call it aphanitic. Aphanitic means fine crystals. Now you can put that in the parentheses underneath it. And that just means that the crystals are so small you don't see them. Now in general, that means you don't see them. You may occasionally see a little, very small crystal, and then for the most part, you can't see them. We would still call that aphanitic. Okay? And if we see a rock that's aphanitic, it tends to be very uniform in color, like one solid color. It could be a light color, it could be a medium color, it could be a dark color, as long as it's pretty uniform. The next one is vesicular, right here on your list. Vesicular means that it has holes. So if a rock has a bunch of holes in it, it's kind of like the Swiss cheese of rocks. It has a bunch of holes. That's formed from quickly cooling off, and that would be an extrusive igneous rock. So it's quickly cooled off. It probably cooled off in something like water. And we know that magma is very hot. When it hits water, it makes that water very hot, and what does that water do as soon as it gets heated up? It's going to, very good, it's going to evaporate. So we get bubbles that form, and those bubbles kind of open up the rock, and we get holes inside of the rock. All right, and the last one here listed is glassy. Okay, glassy means that it's glassy. It's an actual glass. It's classified as a glass. That's the one in class that we will see that it looks like a glass. However, it's not clear in color, it's solid black. It's solid black in color because, as I talked about with some of the classes, it's silicon dioxide, SiO2. And this is one that we looked at in our mineral lab that we said technically is not a mineral because it does not have a regularly repeating internal structure. What it actually has is random Si's and O2's that are mixed up, and because it's mixed up, light doesn't travel well through it. So it gets kind of trapped inside. All light is absorbed, and so it ends up being a solid black glassy color. So that's the one that we will see for the glassy category, although it looks like several that it could be. You'll see how we fill this out in just a second, okay? So now across the top we have composition. Composition does mean what minerals are inside of it, and we'll talk about that in a second, but to begin with, we'll start with the word felsic, intermediate, and mafic. Okay, felsic, I tend to think of what it sounds like. So if somebody felt sick, they would probably be pale in color. They wouldn't feel well. Their color would be flush. And so felsic tends to be light colored. I'll write that on there using my red pen. Light colored. Okay. If a rock is igneous and it's light colored, we'll call it felsic. If it's medium colored, we call that intermediate. Okay, that could be like a solid gray in color, that's a medium color, or it could be like 50% darks and 50% lights. So if it's a phaneritic, coarse-grained igneous rock, we may have, let me draw this on the back, we may have a rock that has a bunch of coarse grains in it that we see, and maybe half of them are dark, half of them are light. If that's the case, it's considered intermediate. Okay, kind of like this. We can see that about half are dark, half are light, but it's coarse grains. We consider that intermediate. And the last one, mafic, I think of like the mafia. Mafic is dark. The mafia is dark. And so once you fill in your compositions, you should have felsic light colored, intermediate medium colored, and mafic dark colored. Okay? Now the composition, really what it means is down at the bottom, and this is which minerals are in it, right? So we have quartz and feldspar underneath the felsic. Quartz is very clear in color, or whitish, and feldspar was number 1 in the lab that we saw. It was the pinkish one. We called it fleshy. All the way over at the right is mafic, very dark in color. We have plagioclase, which was number 2 that we saw in the lab, calcium plagioclase. Now it was considered dark here, or mafic, however it's actually white, and we'll talk about how that impacts this in a little bit. So we get plagioclase, pyroxene, which is black, and olivine, which is dark green color. Okay, so these are all darks except for the plagioclase, which we see very rarely. I'll talk about that in a little bit. So darks, lights, and then here we see the arrows pointing over, right? And that means as we move from left to right, the quartz and feldspar kind of gets less and less and less. And from here, as we move right to left, plagioclase and pyroxene and olivine get less and less and less. Okay? All right, now let's start filling this in. So if we have a phaneritic, felsic igneous rock, phaneritic means coarse-grained, felsic means light-colored, then we have granite, G-R-A-N-I-T-E, granite. Granite can have some darks in it, but as long as it's primarily light-colored and it's coarse-grained, which means we can see those crystals, then it's granite. Now let's stick with the other coarse grains. We'll go intermediate or medium colored. After granite is diorite. Diorite is half dark, half light. Again, it's coarse grained because it's phaneritic. And this is like the one that I drew on the back side and I showed you. Coarse grained, about half and half, 50-50 darks and lights. And then the last phaneritic one that's mafic, or dark in color, is called gabbro. And if I were to color this now, it doesn't have to be completely dark, although it almost always is. Gabbro is going to be coarse grained. We're going to have a lot of dark minerals in it. You don't have to identify the actual minerals. In this case, you just have to identify that it's dark and coarse grained. So this is what it looks like. Okay, so here are our top 3 for phaneritic, granite, diorite, and gabbro. Now I'll move on to aphanitic. I'm going kind of quickly. You can pause if you get stuck at any point and then just continue to play from there. Aphanitic means fine grained. So we go to felsic, light colored, and aphanitic. Again, we might have 1 or 2 kind of small crystals in there, but the majority of it is very fine grained that we don't see. We have a rock called rhyolite. R-H-Y-O-L-I-T-E. Rhyolite. Fine grained and light colored. Now again, if these are fine grained, then they formed at the rocks or at the Earth's surface or above the Earth's surface. So rhyolite is an extrusive igneous rock. It formed at or above the surface. Now we go to intermediate colored, aphanitic. We have a rock called andesite. A-N-D-E-S-I-T-E. Andesite. Fine grained, intermediate colored. Probably like a grayish color, medium gray. And lastly, fine-grained mafic, aphanitic and mafic, dark colored. We have basalt. If you haven't heard of basalt before, You're going to hear it a lot in this class. We're going to start talking about it more and more and more. But basalt is very fine-grained and very dark in color, like a solid black. Now, in general, as we move from left to right, light to dark, we also get higher densities with the darker minerals. And so they tend to be a little bit heavier. Or if we were talking mineralogy terms, the specific gravity is higher. Vesicular means it has holes. Okay, so we have felsic, light-colored. This is pumice, P-U-M-I-C-E. Okay, pumice, maybe you've heard of it, ladies. Pumice is it's a stone that some people use to exfoliate on their skin. So you can still buy it at some health stores. It's just like a white stone that has a bunch of holes, and you just rub it on your skin, or maybe if you've gone to get a pedicure, they'll do it on the pads of your feet. It's kind of gross, but it's really little glass shards stuck together, and so it's technically glassy, although we classify it as vesicular because it has a bunch of holes. And same with scoria, which is the other type of vesicular rock. Okay, so pumice is felsic, light in color. This intermediate one I'll just kind of X out. It could be pumice or it could be scoria. Scoria goes under the mafic category. It could be a dark red in color, or scoria could also be a whitish color, or it could be black in color. So even though it's mafic, it could be light, and the reason is because scoria, it's tough to do this backwards, scoria right here, it can have plagioclase, calcium plagioclase, which is white. So it's considered mafic, however, calcium plagioclase is white. So sometimes it looks just like pumice. It's not very often, but sometimes it does. So here's what you do. Again, the mafic ones are darker, they're heavier, and so you can do something called the float test, which is exactly what it sounds like. I have a jar in the middle table, the middle lab table. All you do is take your rock, drop it in. So if you think you have pumice or if you think you have scoria, it doesn't matter. For your rock lab, this is going to be number 27, although there's no number actually on the rock. So you'll take the rock, you drop it in. If it floats, it is the felsic one, which is pumice. If it does not float, it sinks to the bottom, then it's scoria. So sometimes they can look exactly the same. You have to do the float test. Lastly is glassy. Glassy is obsidian. Obsidian will go way over here on the left, underneath felsic. Again, we said that this is weird because obsidian is solid black in color. Why would we put it in the felsic category? That's weird. Well, the reason is because obsidian is SiO2. It's pure quartz. Again, we go back to the idea that it's SiO2. It's not organized with this internal structure, and so it absorbs light and it looks black. If you were to cut off like a little chip of it, a little piece, it actually would be really clear in color, and that's because it is quartz. It just doesn't have the structure of quartz, and so small pieces are still very clear. It is light in color, but when you get a big chunk of it, it turns black. And then for the other categories here, glassy, it's nothing. Okay, it's yeah, you can just X those out. Okay, just like this. So you should have it all filled in now. What I want you to do is go ahead and get together with a partner, just you and one other person. Go to a lab table and use this chart, which is on the bottom of your lab, and use it to fill in for the rocks choices 21 through 27. Make sure you identify the texture for each one, which is coarse, fine, vesicular, or glassy. But I'm going to have you use the official words, which are phaneritic, aphanitic, vesicular, and glassy. And then composition, tell me, is it felsic, intermediate, or mafic? Tell me, is it extrusive or intrusive? Remember, extrusive forms at the Earth's surface or above, and so it's fine-grained, or it could be vesicular, or it could be glassy as well. And then intrusive would be formed deep inside the Earth. So intrusive, inside the Earth; extrusive, Earth's exterior. Okay. Then lastly, give me the rock name, which you have, and you can use on your chart below. Any questions? Don't ask the substitute. I say that only because I don't expect her to know any of the answers to it. Ask someone else in class, ask your partner. If your partner doesn't know, ask someone else at the table, and good luck. Go, go, go.